solving equations by using the factored form. So taking a look at this, if we are going to be solving using the factored form is a product of two or more linear factors. So what that means is you're going to have something like this, x plus 1 times x minus 1. It's a product of two different linear, meaning degree of 1, binomials, meaning two terms. Zero product property is the product of two factors is 0 when at least one of the factors is 0. So that means if I want to find the solutions, I'm going to have to set each one equal to 0. That gives me x equals -1 and x equals +1, which I'll show you how to do in example 1. The number of x's tell you how many solutions you have. So you can see you had two x's, we had two solutions. Taking a look at example 1, I'm going to set each part equal to 0. So I'm going to have two different solutions here. If I set x minus 2 equal to 0 and solve for x, you add 2 to each side, getting you x equals 2. For the next one, I set x plus 3 equal to 0. You're currently adding 3. The opposite is subtraction. So subtract 3 from each side, you get x equals -3. Those are one-step equations to solve. Those are pretty straightforward. Sometimes you'll have a two-step equation, which I'll show you in this next one. I'm going to set each part equal to 0. So I'm going to have two different solutions here. This one's just a one-step. Opposite of subtraction is addition. So you get x equals 4. Over here, this is going to be a two-step equation because you're both multiplying and adding a number. So the first thing you want to do is isolate the term with the x. So you must subtract 1 first, giving you 2x equals -1. Then to undo the multiplication, you do division, getting x completely by itself, and you see you get -1/2. Take a look at part C. You set each part equal to 0. Now this time I'm going to have 3 solutions because I have 3 different binomials. So x plus 1 equals 0, which actually we just did, so I would subtract 1 from each side, divide by 2. That gives me x equals -1/2. Set 3x minus 2 equal to 0. So this one I must add 2 first. Then I have 3x equals 2. Divide each side by 3. I get x equals 2/3. And then last one, x minus 1 equal to 0. You just add 1 to each side, giving you x equals 1. I'll let you go ahead and do the try problem on your own. For now, let's move on to example 2. So the key with these is that I want you to recognize sometimes your GCF gives you a solution. So let's write that. Sometimes GCF gives solution. So you set each part equal to 0. You set the 5 equal to 0, you set the 3x minus 7 equal to 0, and you set the x plus 3 equal to 0. If you set 5 equal to 0, there's no variable for you to solve for. There's no x. That's just a false statement. So that one is not going to give you a solution. So no solution from that part. But I can solve for x over here and see that I get x equals 7/3. Or over here, I can subtract 3 from each side and see that I get x equals -3. For this one, if I set each part equal to 0, so the GCF, the first binomial, the second binomial, this time, this GCF had an x, which means I can solve for a solution. You're currently multiplying by 2, so let's divide each side by 2. 0 divided by 2 is just 0. So I do have a solution from the GCF. Add 3 to each side, you get x equals 3. And then add 2 to each side, and then divide by 2, you get x equals +1. Everything on the front page was already given to you in factored form. Unfortunately, that's not always going to happen. So if you're ever trying to solve a quadratic by factoring, so we need to get it in that factored form first, here are your steps. Step 1, set the equation equal to 0. Also, might I add, it should be in standard form, which is highest to lowest power, so ax squared plus bx plus c if it's a quadratic. Step 2, factor the polynomial using what you know about factoring. Step 3, set each part equal to 0 like we did on the front page. And step 4, solve each equation like we did on the front page. This will give you your solutions. So when I look here, this is a quadratic. It is set equal to 0. It is in standard form. All these are great. I do recognize this is a trinomial where a is 1, so I can do guess and check, which is where I list out the factors of 18 and ask myself, using same sign since it's positive, what adds to 11? Well, that's a positive 2, positive 9. So my factored form is x plus 2, x plus 9. And now I factored it, which means I can solve it. Set each part equal to 0 and solve for x. You get negative 9 and negative 2. Let's do the next one. So for the next one, we have a quadratic. Now, it's not currently set equal to 0. We do have to fix that. We're going to subtract 10 from each side to move it over, giving me x squared minus 3x minus 10 equals 0. Now, trinomial where a is 1, we can still do guess and check. Now this time it's negative, which means different signs to get the middle term, which is a negative 3. That's positive 2, negative 5. So this is my factored form. And now I set each part equal to 0 to get x equals negative 2, x equals positive 5 when you solve those. For this next one, not set equal to 0, let's fix that. Subtract 5x to each side, giving me 2x squared minus 5x minus 88. Now this time, a is not 1. I cannot do guess and check, okay? Cannot do guess and check. I have to do factoring by grouping. There's no GCF to pull them out, so that's not going to help me. I do have to multiply my first and last term together, which is negative 176x squared. Unfortunately, yes, that is a large number. It has a lot of factors. So if I'm thinking about the factors, 1x 176x, 2x 88x, 4x 44x, 8x 22x, 11x, 16x. It's a lot more factors you have to deal with, but it's still the same idea. Using different signs, I need to pick the pair that gives me negative 5. That's a negative 16, a positive 11. This pair does not give you the factored form. It replaces that middle term. So 2x squared plus 11x minus 16x minus 88 equals 0. And then you factor by grouping. The GCF between these two is x, leaving me with 2x plus 11. The GCF between these two appears to be a negative 8, leaving me with 2x plus 11. So I set my factored form up then, what they have in common times the GCFs, and it's set equal to 0. Then you set each part equal to 0, and you'll do your solving. That gives me x equals negative 11 over 2, because I subtract 11 divided by 2. And over here, that gives me a positive 8. So two different solutions for that one. All right, these are GCF problems, which we haven't run into yet. The first thing I always should do is check for a GCF. In this case, it happens to be a 5x. If I pull out a 5x, that leaves me with x minus 2. Now remember, you set each part equal to 0, including the GCF. So I can set 5x equal to 0 and x minus 2 equal to 0, and then I solve. This side, you divide each side by 5, you get x equals 0. This side, you add 2 to each side, you get positive 2. And that's it. For this one, it's not set equal to 0. I do have to move that 12 over. X cubed plus 3x squared minus 4x minus 12. Now this time I have a cubic. It's not a quadratic. So you might be thinking, how on earth do I factor this? It's 4 terms, guys. You just factored 4 terms right here. Anytime you see 4 terms, we're going to do that factoring by grouping. Group the first two, last two together. The GCF between these two is x squared, leaving me with x plus 3. The GCF between these is negative 4, leaving me with x plus 3. So the factored form is what they have in common by their GCFs. Now you're not done, guys. This is factorable. It is a difference of 2 squares, where a is x and b is 2, because you're asking yourself, what do you square to get these terms? So x plus 3 is out front, and then difference of 2 squares, that's x plus 2, x minus 2, because it's a plus b, a minus b for your factored form. That's your special case. Set each part equal to 0. So I'm going to have 3 different solutions here. Negative 3, negative 2, and positive 2.